But those two cerebral hemispheres in your head are in fact two scalar potential generators and functions. And under just the right circumstances, they can indeed generate fields on the bottom and energy on the bottom, or convergence or cooling on the bottom of your feet. And you can in fact walk across coals because the heat is being cooled at your feet. And there are some folks in Japan who do this once a year as a religious thing, and they do not run across the 1200 degree red hot coals. They stroll sedately. And you can see it any time you want to go to that monastery that time of year and look at it. It's not hard to see at all. It's not hard to measure the coals. It's real, but you can't fake it. You can run out there with all the thoughts in your head you want to, and you just burn the hell out of your feet is what you'll do. The other thing is, did you ever worry about metal bending? Have you ever been to one of Jack Houck's metal bending parties? Anybody in here? Well, there's a few that have. Jack's a good scientist. Conventional scientist, but he got curious about the phenomena, and he gives these parties to see if people can't bend metal. He gets 80% of them on the average to bend metal. I've bent metal. My wife bent metal. And now the metal we bent was very simple. I held a knife, and she held a fork between these two pinkies, and I held it by the end. I did not have this on the knife, nor did she have this on the fork. And when everybody got in the right mood and things began to happen, all of a sudden, at exactly the same instant, her fork laid over and the tines began to furl around like that, and my knife laid over. And I'm holding it between these two little pinkies right here. And I defy any physicist to honestly do that experiment within the bounds, replicate that within the bounds of present theory. You can fake it like a magician does, deceive you to look somewhere else and substitute the fork or the spoon. But you can't do it on camera without any change at all. And I like to think of a special I saw some time ago in the South Sea Islands of the amazing Randy watching the natives stroll sedately across the red-hot coals and shaking his head and saying, "I have no explanation of that. That's on tape." Next slide, please. Oh, no, let's go into this one. This one's very important. Well, we're talking about all this energy and all that stuff. We never did really say what was out there in the vacuum, did we? We said there's no electric fields, and we said there's no magnetic fields. But the Cajun comes back and says, "Well, Tom, what in the hell is out there? You done got rid of the ducks. What else is left?" So we said, we got a strange kind of them duck that Einstein dug up called them space-time. That's what exists between the transmitter antenna and the receiver antenna. Space-time, nothing else. But ladies and gentlemen, in general relativity, space-time is an active medium. The geometry is active. It acts on mass. Mass acts on it to curve it, as Wheeler says, and the curvature of space-time acts right back on that mass to produce a force on him and to move him. Space-time, when it changes, when it curves, is active upon mass at whatever level you take. As a matter of fact, it views all the forces being generated by the interaction of a little curvature of space-time on a little piece of mass. Every force can be represented that way. So what happens is, when we shake up these electrons and we eliminate from our thinking the fact that we also shook up the nucleons and the nuclei, the protons. But anyway, we agitate and curve the space-time. And what actually gets formed is an oscillation of space-time curvature, a pure general relativity wave. And what propagates through space-time is this propagating space-time curvature oscillation. Now, when it strikes the electrons down in the receiving antenna wire, being a space-time curvature propagation or oscillation or disturbance, it does what such disturbances do. It works on the mass that it hits, and it oscillates those electrons. They can't oscillate longitudinally, so they move sideways, and we get our transverse electron wiggle waves in all our detectors. But the wave in the interim is a general relativity wave. So hidden inside electrodynamics has always been general relativity. And we never knew it. And it's a very powerful general relativity, far more powerful than our physicists go off chasing, particularly in astrophysics, because it uses the strong electromagnetic force as the agent of curvature, not the little old weak G-force. You don't have to have a humongous collection of mass. Now you can do it with little bitty stuff on the lab bench. You don't have to be out in the interior of a neutron star. All this stuff we're talking about in astrophysics can, at least in theory, now be engineered on the bench if we pay attention now to the general relativistic curvature waves that we can create and what we can do with them. Next slide, please. I want to be a little more exact on this for those of you that are technical. Basically, electrodynamics today, because of the still assuming the material ether, if I look at transfer functions, transformations, the equations are transformations from mass perturbation to another mass perturbation. That's all. They have nothing to say about what goes on in space-time. Nothing whatsoever. They are missing two enfolded transformations, shown in black. On the left, matter to space-time transformation, where we produced now a general relativity wave of the oscillation of space-time curvature. And over on the right, when that reacts back upon mass in our receiver, it produces again electron wiggle waves. So we really go from electron wiggle waves. Electrodynamics tells us how the next electron wiggle waves will work. There's nothing wrong with that. It works fine. But it won't give you how to engineer what's in the middle. It'll just do it automatically, and that's it. You can't get refined in the art. But what actually happens is we put in these two extra functions. First of all, we made a perturbation in space-time. That propagated down to the other receiving antenna and reacted on those electrons to produce that transverse wave. So those hidden two transformations are actually nothing but hidden general relativity, but the electrogravitation. This is the secret of electrogravitation, right down on this slide. If you want to do anti-gravity, you're going to have to understand this in your head. Next slide, please. When you make forms of these curvatures of space-time, I use two names to speak of those. I took the names basically from other folks. They're not original with me. One is space-time curvature engines, because they act on mass like an engine would and do some action. And the other is vacuum action, because they twist up the vacuum. If you're considering that a vacuum instead of space-time, okay, you're in quantum mechanics, so what? You change all the particles, and you change the particle flux, and the density of the particle flux, and the direction of the flux, and all of that stuff, and it still has the same effect on the other end. One way you looked at it with wave theory, the other way you looked at it with particle theory. Same result. Now, the difference is this. If you receive a signal and you are the receiver, you have some choice about whether you do that or not. It says, hey, Tom, I want you to leave the platform and go out the back door. And I say, hey, man, I ain't finished yet. I'm going to keep on till I finish, or they run me off on the rail. But if he sends you a vacuum engine, it don't say nothing to you about that. It grabs a hold of you and drags you out the door and throws you out in the street. You see the difference? One is the deliverance of a request. What I would like for you to do, if you would be so willing as to do this. And the other one is not just an order. It's an engine that goes in and grabs it and does the action. Wasn't that nice? If I want to do stuff with matter, should I keep using signals? Well, maybe the matter, if I find how to trick it, maybe I can get it to do it, maybe I can't. But if I hit it with an engine, it doesn't have a choice. All I have to do is learn how to tailor the engine. Now, I'm using applied electrogravitation. I'm using general relativity, but initiated with the strong electromagnetic force as the agent of curvature. I'm doing something very precisely. Yes? What happened? So much of my work in the last years